Bonjour à ceux qui viennent de nous rejoindre, je vous laisse vous installer. Donc, je vais donner la parole à Hiba de chez Smile qui va nous, par rapport à la première conférence qui était plutôt très haut niveau, on va redescendre un petit peu dans l'infrastructure as code. On va parler Terraform, on va parler construction d'infrastructure. Donc Hiba, je te laisse la parole.
Okay, merci. Hello, everyone. This presentation will be in English language. So I am Hiba Awad, a PhD student at Smile Company, and I am T-Atlantic. So today I will show you how to automatically generate, test, and deploy Terraform configurations. So in this presentation, I will provide an introduction as a problem that my thesis aim to solve in general, and we will talk about the fog system lifecycle with a focus on very fog ops, along with its demo, and finally a short conclusion. So Smile Company is an open source service provider with more than 2,000 employees, 17 agency, and 32 years old of experience. So I'm doing my PhD in R&D team in Smile. Along with IMT Atlantic Teams Stack and now more specialized in modeling of distributed systems and the cloud infrastructure. So our topic today is about fog systems. Why fog? Because it brings a lot of benefits, like reducing bandwidth usage, limiting latency, minimizing data centers, transfers, and etc. So, but with these benefits came some challenges like management challenges related to size, complexity, heterogeneity of these systems, and QoS, quality of service assurance. So our solution will address these challenges and provide a generic model-based approach with a model checking solution in order to address the first three challenges. And we will provide a design to deployment transition, and finally quality of service assurance at the pre-deployment time. So the fog system lifecycle for us is this in general. We didn't study the system after deployment, post-deployment, because in the literature we found that there are a lot of solutions discuss challenges of fog systems or distributed systems after the deployment. So that's why we wanted to study the life cycle from the design to the deployment. So for the system design and conception, here we will have the design of the architecture of these systems. Here we will have the topology and the configuration of each actor of the system. You have fog nodes, IoT devices, etc. And the output of this phase will be YAML files, where you can find the description of each node. And in order to reach the deployment, we need infrastructure as code scripts. So in order to have that, we will have a phase called system preparation. So here we will have this transition between the design and the deployment. Specifically the infrastructure as code scripts, which are for us deployment configuration files. It is like Terraform files, Kubernetes files, etc. So in order to make sure that the design system and these configurations, generated configurations are satisfied, so we will have a phase called system testing and verification. Here we will have a verification of the quality of service constraint. So if the user has some quality of service requirements, he needs to put these requirements in order to be verified in the system, make sure that everything is good before doing the actual deployment of the system. And at the end, we will have the actual deployment of the system. And usually, companies use DevOps practices to do that because it brings some automation. So specifically CI/CD pipelines. So that is what we did, but with our touch. So we leverage the CI/CD pipelines. So I will show you here the big picture of my thesis. Here we will have a model-based approach with DevOps practices. And the goal is multi-level verification of quality of service requirements. So we have developed 3 solutions. First, we will have our first actor is fog system architect. His first role is to specify the fog system model. So here he will specify the YAML files he want to deploy the architecture of the system. He will define what is his system. And this fog system model will be conformed to a meta model called fog modeling language. This language will allow the fog system architects to design any fog system in any application domain. So this fog system model will be an input for our first solution, VeriFog. And VeriFog will do the model checking. So by querying this model, he will the solution will see if there's a problem or not. If there are some problems, updating reports will be generated, so the fog system architects can review these reports and refine the model. And he can refine the model as much he need to, at the end, have the satisfied fog system model. So now he has the satisfied fog system model. His second role is to specify which deployment tool he wants to use in order to deploy the system. So for example, he can say, I want to deploy the system with Terraform. I want to deploy the system with Kubernetes. I want Docker Compose. So he will specify these tools. And our second solution, VeriFog++, will take these tools and this fog system model to generate the deployment configuration files. So here we will have a lot of deployment configuration files for a single fog system model corresponding to multiple deployment tool. So here we have like a problem. I have a lot of deployment configuration files corresponding to a lot of deployment tools. So which one I will choose? That's the first role of our third solution, VeriFog Ops. So having these files and a very interesting input, which is deployment instruction. Here we will have the quality of service requirements specified by the user. So he will, VeriFog Ops will take this instruction along with these deployment configuration files. He will do the selection of the best one or the most appropriate deployment tool. And if the verification is done, is valid, so he will have the it will go to the deployment automatically. And if not, there are some failure reports that will be generated, and the system ops engineer will see this failure reports and takes the decision. So now we will focus on this part. So VeriFog Ops, as I said, our fog system architect will specify the deployment instruction. This deployment instruction will contain all the quality of service requirements. For example, you will have like cost, security, configuration, syntax, anything. And after that, the deployment configuration files are injected because we had generated them from the other solution. And here, the goal of the DevOps engineers to do the matching deployment tools quality of service solution. So, for example, if the deployment tool here is A, it's Terraform, and the quality of service requirement in the instruction is cost. So to predict the cost of Terraform files, we will have infra cost as a quality of service solution. So he will do this matching, and there is here a CI/CD pipeline. It is not a pipeline for deployment. It's just for the selection. So after the CI/CD selection pipeline, we will have the output deployment most appropriate deployment tool, along with its corresponding deployment configuration. And after that, the satisfied or the most appropriate deployment tool along with this file will be transmitted to the second step infrastructure deployment. Here, we will have the deployment instruction and these files as input to domain-oriented CI/CD generator. So why it is domain-oriented? Because we developed this just for Terraform. So if it is Terraform and you have the quality of service requirements here by the user provided by the architect, you will have the automatically generation of the CI/CD file. For example, a GitLab CI. And this GitLab CI will generate a pipeline on gitlab.com. And this pipeline is generated automatically by this domain-oriented CI/CD. And depending on the status of this pipeline, if it is valid, so the deployment is done. If not, the failure report will be generated, and the sysops will take the decision on whether to change the instruction or the configuration file. So now we will have a demo. Okay, so here is the deployment instruction file. You will have the quality of service requirements, its cost and security with their rules, for example, budget, the status of the pipeline, if it is a test blocking or not, and the priority of the selection. So if I have two tests, which one I will prioritize for the selection of the most appropriate selection deployment tool. So now we will have the CI/CD selection pipeline running, cost and security as in the instructions. The selection will choose the most appropriate deployment tool. Here we have our priority is the cost. Terraform is cheapest than Kubernetes because we have as input Kubernetes and Terraform. And the selected choice is Terraform. Now we will have the auto generation of the CI/CD file. Okay. Here is the CI/CD file. So Terraform is selected, so the transfer of AWS point TF is done. Now we will have the CI/CD running pipeline. It is infra cost and TFSec because we have cost and security, but for Terraform it is infra cost and TFSec. These are the quality of service solutions. So TFSec, if you remember, it was optional, not blocking the pipeline, and infra cost was blocking the pipeline. So here we have just warning, not blocking. The infra cost will block the pipeline because it was blocking, and the failure report said cost exceeded budget by $32. So now the sysops will take the decision on whether to change the budget here or to change the deployment configuration file of Terraform. So as a conclusion, today we talked about VeriFog. It's a fog system model checking, and actually it is an article. It took the best paper award. And the second solution was for automated generation of deployment configuration scripts. The third one was VeriFog. We had a focus on it with 2 levels of verification for the selection and for the deployment. Thank you.
Merci beaucoup, Hiba. Donc, pour les questions, je ne sais pas si en anglais ou en français.
C'est la même.
Donc, n'hésitez pas si vous avez des questions. Ils sont timides ce matin. Ils sont très timides.
Oui.
Donc, encore une fois, n'hésitez pas à solliciter Hiba derrière si vous voulez aller plus loin sur le sujet. Merci beaucoup, Hiba.
Merci à vous.